Assalamu alaikum. Hello everyone. Let me just start by saying a few words about my background. My name is Mohammed Alameen. I am a PhD student in Petroleum Engineering Department, University Technology Petronas. Today I would like to talk about quartz hydrolysis analysis of pure quartz for enhanced oil production, influence of time, pH, and salinity in hydrolysis. So my presentation today will be divided in several parts. Introduction, background of the study, objectives, research methodology, experiment, result and discussion, conclusion and recommendation. Finally, I will wrap up with the question and answer session. So it is no secret that sand production has a huge concern in petroleum engineering since it may induce many problems. For example, damage of equipment. Also, sand production is identified both mechanical and fluid flow effect. So the first effect here, as we can see, it is mechanical impact, which is inside the reservoir caused by shear, tensile, or compressive failure. Actually, this is related to the stress on the rock strength. While the second impact here is the fluid flow effect. As we can see in the figure here, when the fluid flow go through the porous media inside the reservoir, this fluid flow induce force or pressure. This force will make that sand started to touch and overcome the rock strength. So this study aims to evaluate the quartz hydrolysis. This quartz hydrolysis is a chemical reaction between quartz here and water. This chemical reaction play a main role in reducing rock strength. Also the influence of time, pH and salinity on the hydrolysis. So as we can see from the figure here, actually there is two types of formation condition. The first one here, as we can see from the figure, is initial condition, where only cannot water will be present or available inside the reservoir. Here, there is no chemical reaction between water and quartz because there is no water and saturation water will be the low value. While here in the second scenario or second initial, after the water injection process inside the reservoir, the water saturation increase and this lead to quartz and water to connect and the chemical reaction between them take place. This lead to chemical reaction to reduce the strength between the quartz. So as the summary of that, the effective rock strength is highly affected by increase in the water saturation, especially during water injection process. The effective rock strength will be significantly reduced by increasing the water saturation, leading to the high sanding amount. So here I will discuss the quartz hydrolysis related to the rock strength. Actually, as we can see here, the rock strength, it's only come from the cementation of the rock. So as we can see, as the water saturation increase, the quartz hydrolysis will take place and there is a chemical reaction happen between water and quartz. This leads to quartz hydrolysis affected and change in the surface energy of the quartz. This leads to the silica to dissolve inside the formation, resulted in the silica dissolution. After that, we will have reduction in the rock strength. So, from this point, our objective to study here to develop a correlation between silica dissolution at different reservoir conditions. So here, the silica dissolution will be at coarse and fine particle by measuring silica dissolution, also at different pH salinity solution at ambient temperature. Also using different type of brine, for example, sodium, potassium, magnesium, and calcium chloride, which is represent seawater and also the formation water inside the formation reservoir. Also investigate the different silica dissolution for coarse and fine particles. So as literature review, there is many study focused on related between the water and reduce in the strength, but no one can relate it to this chemical reaction which is called quartz hydrolysis. So there is a study in 1966 test the strength of the 5 samples of the sandstone and find that the UCS of the water saturated sandstone were about 7 to 46% lower than the dry one. While another study found also the UCS of the quartz rock in the wet condition is about half of that in the dry condition. And GPT stuff also found that 50% of the reduction in the UCS due to the brine saturation in the triaxial test on the sandstone. Also here, as we can see, the field observation, it's happened, the studies for the sand production wells in the North Sea. They found that 21% of the sand production following water production within a period 100 days. For 100% of the well, the onset occurred before 100 days of the water breakthrough, while the other cases did occur more than 100 days after water breakthrough. So here our methodology for the experiment. So first of all, the mixture has been done with mix 5 grams of the crushed quartz with 45 milli of the solution. This solution is different pH and different brine. Then we place it inside the water bath, as we can see here, for 60 hours. Then we will discuss why we have select the 60 hours. Also using centrifuge to clean the solution in order to measure the silica dissolved by UV vis. This is the equipment for UV vis. So as the result and discussion, the first result here, quartz characterization test. Actually, I use the XRD equipment in order to know the purity of the quartz. So as we can see from here the figure, the result of XRD result confirm that the quartz is about 97.7% pure quartz and only 0.3% is another contaminated, another material. So the second result here for the time effect. Here we can see the time effect on the silica dissolution. First I start with 24 hours and see and read the silica dissolution. Then after that I increase the time until I reach 72. So as we can see from the graph here, as the time increase, there is increase in the silica dissolution until we reach 60 hours. This is the time equilibrium. So after this time, there is no more silica will take place and react. That's why this is 60 hours here have been selected to be a set time. At this time, the reaction at this called equilibrium condition. So here we can see the effect of pH and also the effect of the coarse and fine particles. As we can see from the result here, as the pH increase, there is increase in the silica concentration until the pH reaches 12. This is the highest amount of the silica dissolution among the whole pH value. Also, we can notice that the silica dissolution increase when the decrease in the pH. As we can see, after pH decrease until 3 value, we can see gradually increase in the silica dissolution. Also, regarding the particle size effect, it shows that fine particle here we can see it's high more silica dissolved than coarse particle. This is the reason behind the change in the surface energy. As we can see that the fine particle has more surface area than coarse particle. So moving to salinity effect, as we can see here from the graph, the salinity effect has see in the silica dissolution. Here I have used 4 types of the brine: potassium, sodium, calcium, and magnesium chloride. So I can see the salinity effect. It was seen that the sodium and potassium chloride has the highest effect, as we can see here, for all concentration, comparing to the lower silica dissolution was found in calcium and magnesium chloride. So as a conclusion here, quartz hydrolysis, it's a chemical reaction, play a main role in reduce the sandstone strength. So also we can notice that the effect of time shows the reaction reached a state of equilibrium at 60 hours. So also the particle size effect indicate that the fine particle has a greater dissolution than the coarse particle, which is related to the change in the surface area, as the fine particle have a higher surface area, enhancing the surface reaction. Also the effect of pH. The highest amount silica dissolution was found on pH 12 and pH 3, then pH 3. This means that silica dissolution increased sharply at the highest and lowest pH. This is related to the hydroxide and also hydrogen ion in both high and low pH stimulate the reaction. Regarding the salinity effect, it was seen that sodium and potassium chloride have the highest effect on the silica dissolution comparing to the magnesium and calcium chloride, which are the lowest. Recommendation: actually enhance the strength or keep the strength of the formation in the same value. It is a must to reduce the sand production. So present a chemical material or inhibitor that reduce the chemical reaction between sandstone, quartz, and water will enhance the rock strength. As a part of that, sand production will be controlled. So now it's question and answer session. Thank you all for your listening.